In this video here, we're going to take a look at exam revision for 3D vectors. So for this video then, all we're going to do here is answer a few exam style questions based on 3D vectors. And as you can see then, this will cover the following topics here. So what do we have then? Well, we have vectors in 3 dimensions. We have solving geometric problems. And then finally here to finish with, we have applications to mechanics. So as always here, what I would recommend is that you pause the video and have a look at the questions as they appear, and then just double check that your solution matches what we get on the screen. So that should give us everything that we need here to get started. Let's begin now then with question 1. So let's just get started here then with question 1. So as we can see then for question 1 here, there's not really a whole lot going on. We're just given that minus 4i plus 50j plus 36k is equal to 2ai plus 2 plus bcj plus 6ack. The question just wants us to find the values of a, b, and c. So we can easily do this then just by equating coefficients here. Let's just make a note then that we need to equate coefficients. So equate coefficients here. Okay. So if we equate coefficients then, in this case here, minus 4 is equal to 2a, okay? In fact, let me just do this in different colors here, just so you can see how this matches up. So for the first one then, let's do that in orange. So minus 4 is equal to 2a, okay? So if we put the a here, the variable on the left-hand side, so 2a is equal to minus 4. Divide through by 2 then, what we obtain here is that a is equal to minus 2. Hopefully nice and straightforward there. So now let's do the next one here in blue. So in that case then 50 is equal to 2 plus BC. Okay. So 50 is equal to 2 plus BC. Okay. Now we've got two unknowns here. We've got B and C. So at this point here, we can't solve this equation. So let's just continue. Let's do the next one here in green. So to finish with here then, 36 is equal to 6ac. Okay, so 6ac then is equal to 36. Okay, well, we can divide both sides by 6. So ac then is equal to 6, and a is equal to minus 2. So minus 2 times c, we get minus 2c. Is equal to 6. So in that case then, divide both sides here by minus 2. As you can see then, c is equal to minus 3. And because we now know the value of minus 3 here, we can now go on to solve the second equation here. So if I go back to the correct pen color then, what we get here is 2 plus bc is equal to 50. Well, c is minus 3. So what I've got here then is bc is equal to 48. And then finally here, if c is equal to minus 3, what I've got here then is minus 3b is equal to 48. Okay, so to finish with then, let's just divide both sides here by minus 3. And in that case then, b here is equal to minus 16. Okay, so to finish with then, let's just state the values of a, b, and c here. Therefore, a is equal to minus 2. B here, as we've just evaluated, is minus 16. And then finally, C here is minus 3. Okay, so hopefully nice and straightforward there just to get us started. That gives us the solution to question 1. So moving on to the next question here then, let's have a go now at question 2. So for question 2 here, what we're told then is A is the point for 0 minus 2. And b is the point 1, 5, 1. And then the question wants us to find a few different things here. So for the first part then, part A, hopefully nice and straightforward, all we want to find here is the vector AB. Now for the vector AB then, this will simply be the vector OB. So it's the vector OB minus the vector OA. Okay. So the vector OB then is simply this point here, 1, 5, 1. I've got 1, 5, 1 there, minus the vector OA, which is simply this point here, 4, 0, minus 2. So 4, 0, minus 2 there, like so. And if we evaluate this here then, 1 minus 4 is minus 3. 5 minus 0 is just 5. And then finally 1 minus minus 2 gives us 3. Okay, so we get minus 3, 5, and 3 there. Okay, like so. So this here then is the vector AB. And you might prefer to express this here then as follows. So this is minus 3i plus 5j plus 3k. Okay, either's fine here, but just so you're aware then, we can present this in either form. So that's the solution to part A. Now for part B then, let's just do this underneath here. So it says, find the unit vector in the direction of the vector AB. So for the unit vector then, let's just make a note here. So unit vector in the direction of the vector AB. Then the first thing that we need to find here is the magnitude of this vector here, the vector AB, which coincidentally then we've just found here in part A, right? So the magnitude here, let's do that over to the left here. So the magnitude of the vector AB then, nice and straightforward here, right? We have the square root. So we do minus 3 squared. So minus 3 squared plus 5 squared. So plus 5 squared plus 3 squared. Okay. So if we evaluate this here, then what do we get? So I've got 9 plus 9, so that's 18. Plus 25, so that gives me 43 there. So I've got 9 plus 25 plus 9, which, as we've just mentioned, right, is the square root of 43. So root 43 there, like so. And now for the unit vector then, in the direction of this vector here, AB, it would simply be this vector here, the vector AB, divided by the magnitude. Okay, so therefore, unit vector in the direction, I mean, it was somewhat redundant doing it at the beginning as well, but it doesn't matter too much. So unit vector in the direction of the vector AB then. So this is given as, so what do we get here then? So we get minus 3 over root 43. So minus 3 over root 43. I there, like so. Plus 5 over root 43. Plus 5 over root 43. J there. And then finally 3 over root 43. So plus 3 all over root 43 there. Okay, like so. And there we have it. So this here then gives us the unit vector in the direction of the vector AB, giving us a solution to part B. And then finally, for the very last part of this question here, part C, all we want to do then is find the angles that the vector AB makes with each of the positive coordinate axes to one decimal place. So for part C then, let's just do this here underneath. And let's just begin then by considering the angle that the vector AB makes with the positive x-axis. So the x-axis here then, let's just make a note. So for the x-axis here then, we denote this as theta subscript x, so theta of x then, and this is equal to cos inverse. We take cos inverse then of this value here, this coefficient then of our unit vector I. So cos inverse of minus 3 all over root 43, like so. So obviously all you need to do here, right, is just put this into your calculator. And if you do this correctly and run it to one decimal place as the question asks for, what you should hopefully obtain here then is 117.2 degrees. So 117.2 degrees there. So moving on then, let's have a look now at the y-axis. And again, let's just make a note here underneath. So for the y-axis here then, in a similar fashion, we denote this as theta of y. And again, all we do here is we take cos inverse, but this time now, we take cos inverse of this value here, the coefficient of our unit vector j. So cos inverse of 5 all over root 43, like so. And what this gives us here then, you just put this into your calculator, is 40.3 degrees. We get 40.3 degrees there, like so. And then finally for the z-axis here, so for the z-axis here, so that's theta of z, like so. Again, we just take cos inverse here. And in this case here, we take cos inverse of this final coefficient. So the coefficient then of our unit vector k. We get cos inverse of 3 all over root 43. Like so there. And again, all you need to do here is just put this into your calculator. And if you do this correctly then, writing your answer to one decimal place, what you should hopefully obtain here is 62.8 degrees there. Okay. And there we have it. So that gives us the solution to the very last part of this question, part C. And that gives us the solution to question 2. And then finally moving on to the very last question here then, where we have question 3. So for this question here, we have a particle of mass 4 kilograms that is in static equilibrium and is acted upon by 3 forces given as F1, F2, and F3. So for the first part of this question, then part A, all we want to do here is find the value of the constants A and B. So for part A then, we can just note here that if the particle is in static equilibrium, what that means then is the sum of the 3 forces, so that's F1 plus F2 plus F3, this here then is equal to 0. So all we need to do here then is take the coefficient of each unit vector, add those together for each vector, and just set that equal to 0, right? So what I mean by that then is, for example here, 2 plus A plus minus 1 is equal to 0. So 2 plus A plus minus 1, which is just the same as subtracting 1, is equal to 0. And what we can do here then is solve for A. So in that case here we get A plus 1 is equal to 0. So A is equal to minus 1. Nice and straightforward there. Now for the unit vector j, this just cancels nicely because 1 minus 1 is 0. So that's absolutely fine there. We can't do anything else with that. And then for the unit vector k here, we have minus 3 plus 1 plus b is equal to 0. So minus 3 plus 1 plus b is equal to 0. Okay. Solving for b then, so we get b minus 2 is equal to 0. So if we solve for b then, we obtain that b is equal to 2. Okay. And there we have it then. So nice and straightforward. That gives us the solution to part A. Now for part B then, we're then given that F1 here, that's this force here, is removed. And for part B then, we just want to find the resultant force R. So for part B then, the resultant force R here is just equal to F2 plus F3. Okay. So in that case then, F2 here is AI, where A is minus 1. We get minus I minus J plus K plus F3, where F3 then is minus I plus BK, where B is equal to 2. So you get minus I plus BK, where B is 2, so plus 2K there. Like so there. Okay. And if we just simplify this here, then what do we get? So minus I plus minus I, that just gives us minus 2i. So minus 2i. I've got minus j. There's no more j's on this side, so we just get minus j there. And then finally k plus 2k here. That gives us plus 3k. Okay. And there we have it. So that is the resultant force there. Giving us a solution to part B. Now for part C then. So for part C here, we want to find the acceleration of the particle, given your answer in this form here. So in other words, the acceleration vector. So to find the acceleration vector here, we're going to use F equals ma. Okay. The force then is equal to the mass times the acceleration. So the mass here is 4. So m is equal to 4. The force here, F, that is this resultant force then. So if we put that all together, what I've got here is 4a is equal to, so in this case here, my resultant force R, so minus 2i. So minus 2i minus j plus 3k. Okay. And in that case then, if we just want the acceleration vector here, what we do here then is divide through by 4, right? This coefficient here. So the acceleration vector A is equal to, so what I get here then is minus 2 over 4, so that's minus a half I there. So minus a half I, like so. I've got minus j divided by 4, so minus 1 over 4 j there. Minus 1 over 4 j. And then finally here, 3 divided by 4, so plus 3 over 4 k. Like so there. And don't forget the units here as well, right? We're talking about acceleration here, so this is meters per second squared, which was given to you here anyway, but just in case you forgot. So meters per second squared there. Okay. So that gives us the solution to part C. So moving on to part D then, which is simply a nice follow-on from part C. So for part D here, all we want to do then is find the magnitude of the acceleration vector. So the magnitude then of the acceleration vector here, A, is given as, so what we do here then is we take the square root, we take the square root here of, so what do we do then? So we take minus 1 over 2, we square that, we then add on minus 1 over 4 squared, and then finally we add on 3 over 4 squared. So altogether, that would look like the following. Get minus 1 over 2 squared, plus, so what do we get here then? So minus 1 over 4 squared. And then finally here, plus 3 over 4 squared. Like so. Now, you put all of this here then into your calculator. So what you'd get here is the square root of 7 over 8. Okay? So all you need to do here then is just put this into your calculator. And if you round this to say 3 significant figures here, then what you would get is 0.935 there. So 0.935 meters per second squared. Okay? And there we have it. So that gives us the magnitude of the acceleration vector, giving us the solution to part D. And then finally, for the very last part of this question here, part E, all we want to do then is find the angle the acceleration vector makes with the unit vector k. So in that case here, for the unit vector k, this is just the same as considering the z-axis, right? So in that case, then we've got theta k here. So theta k is equal to cos inverse. So we do cos inverse here of, so if it's the z-axis, it's this coefficient here, right? So 3 over 4. We do 3 over 4 divided by the magnitude then, which in this case, right, is the square root of 7 over 8. So 3 over 4 divided by the square root of 7 over 8, like so. So just put this here then into your calculator, right? So cos inverse of 3 over 4 divided by the square root of 7 over 8. And if you do this correctly here, then what you should find, do one decimal place here, is you get 36.7 degrees there. Okay, so 36.7 degrees there gives us the solution to the very last part of this question, part E. And that gives us the solution then to the very last question for this video here, question 3. And that brings us to the end then of this video here on exam revision for 3D vectors.